Hello, Applied 30. It's been a while. I hope you like our new set for the foreseeable future. Basically, I took the whiteboard sheets from our class, and then I've just pinned them all to my wall over here so that we have something to work with. You wouldn't believe how expensive it is to actually buy a whiteboard, so we're going to make do with this for now. I understand that you'll see some of the seams are darkening just because I've been recording on this already. I'll do my best to keep it clean, and hopefully it's not too much of an issue, but hopefully you're okay with working with what we've got so far. Today, we're moving along in our stats unit. We're looking at normal distribution. So I'll have a few notes to give you. I should point out that this topic, it's very easy to get overwhelmed with normal distribution because there's a lot of numbers and a lot of graphs that if you haven't seen them before, they might be just a little bit intimidating. I need you to bear with me here. We'll work through an example and I'll give you some practice to work through. I can tell you right now, like the first 3 questions of your practice, you might take a lot longer than you usually would to get through those. But by the time you're done with the practice on this topic, you'll be pretty strong with normal distribution. Without further ado, let's look into some notes though. Okay, so the first thing we're going to look at is something called a normal curve. A normal curve, it resembles a bell. So if you ever heard of a bell curve, or if you heard of somebody grading or curving your grades, we're referring to something called a bell curve. It's a really nice shape, nice pattern. It represents a normal distribution. Okay, so you would have seen these in some form before. If not, though, let's take a look at what an example looks like. Yeah, and that's our typical bell curve. I realize I didn't write that, so let me just get that down there for you. Okay, so this is what a normal distribution should look like. This is a normal curve. And there's some important information that we can get from the curve. This middle line in the middle of your curve, that ends up being your mean. Your mean is denoted by the Greek letter mu. Looks like this. It's kind of like a backwards U, but we call that mu. If you're not comfortable using mu, you're more than welcome to use x bar, which is what we've been using so far. And that's just an x with a line over top of it. Now, the other pieces of information that we can get are where all these other intervals happen. When we looked at graphs previously, we looked at histograms, which we're using intervals, just like we're using over here. But we also looked at frequency polygons, which use the midpoints of those intervals. And that's actually where this graph comes from, but we'll see that in just a second here. Each of these intervals is relating our mean to what we call our standard deviation. And we've seen that previously. So this first interval, anything that's less than the mean, is the mean minus your standard deviation. That first interval after your mean is your mean plus your standard deviation. And this is true with any normal distribution on a normal curve. This will always be valid. Now, there are some other intervals that you're going to see on these graphs as well. If we can do your mean plus or minus your standard deviation, we should be able to do your mean plus or minus double your standard deviation. And that's where your next interval comes into place. My apologies for smushing it in there. I'm just trying to show that it all does fit on that one graph. There's a final point that should exist on our interval, and that's going to be the mu, or the mean, plus or minus 3 times your standard deviation. And that's right at the end of your bell curve. So it only covers a very small sliver. Are you still with me? This is a really tricky topic to wrap your heads around. We're just going through some of the lingo, the words that we use to describe. And then when we look at an example, hopefully we can see the use for this. But this is what our normal distribution looks like. And each of these parameters, each of these intervals, tells us what percentage lies within that curve. For example, if your data is within 1 standard deviation of your average or your mean, so that means you're either plus or minus your standard deviation, then you're in this area here. I'm going to shade it in. In that shaded area, if you have a normal distribution, it will always account for 68% of your total data. Okay, so if you have a whole bunch of data together, 68% of your data points will fall within that first standard deviation. So if you can imagine these were your grades on a test, for example, most people will average around somewhere, right? That's what we calculate an average and a median and such. And then 68% of people will be within that average to a certain extent. It depends on what our standard deviation is, and we'll see how that changes a little bit later on. Our second set of intervals, which are 2 times your standard deviation away, so 2 standard deviations away, that's this segment over here. You can see it covers a much larger portion. I'm going to shade this in. I'm just going to cross in the other direction though, so you can see it's a separate part. And again, if you have a normal distribution, 95% of your data, so almost everything, is going to lie in that area there. The last parameter that we have is also significant, and that's the 3 times your standard deviation. So if you're 3 standard deviations away, either greater than or less than your mean, then you're going to be in this last segment, and you'll notice it covers almost all of the graph. And that's because it covers 99.7% of all your data. And that's the idea of the normal distribution. If we have a normal distribution, so we have a graph that looks like this, we have that nice bell curve, we can see where people's data is falling into place. So if you're within 68% of the data points, you are likely within 1 standard deviation of the average. If your data falls into 99.7% of all data points, well, then you're within 3 standard deviations of the data. The other thing to keep in mind here, and you will see problems like this in your practice, and again, I promise if you haven't wrapped your head around this in this is 3 minutes of video so far, if you haven't wrapped your head around this just yet, it's okay. You're going to realize though that each of our intervals is divided. We have half of it which is less than our mean, we have half of it which is more than our mean. So if these 2 middle sections here within 1 standard deviation are equal to 68%, that means that each half, so this portion here and this portion here, both account for 34% of your data points. Okay, so that's quite a bit, but we'll work through this.